Hey Algebra 1 people, I wanted to go ahead and make a video about how to graph quadratic equations in Vertex form. So this is a form that I think you guys will find pretty fun and pretty easy to find our vertex, which is why it's called Vertex form. So first I want to introduce this concept using knowledge that we've already learned. Okay, so let's look at this first question. Put the following quadratic in standard form, so in this form, using the box method and combining like terms. So if we have something that looks like this, we can use our box method. If y'all remember what this looks like, we set up a box and then we're going to do x plus 2, then x plus 2 down here. We'll multiply, so it's x squared, 2x and 2x, 2 times 2 is 4. And so, hopefully y'all can see this. Let me zoom in a little bit. There we go. So I basically just set it up. I use this, put one expression here, one expression here, then I multiplied. Then from there we combine. So we get x squared plus 2x plus 2x plus 4. But you're like, Miss Gardner, why didn't you just skip a step? I totally could have skipped a step, so sorry y'all. Right, we could have just added these together. Alright, but y'all are like, Miss Gardner, you forgot something. Yeah, I did. What'd I forget? I forgot to add this 4, okay? So we did this part. Okay, now we're just gonna add 4 over here. So we'll do x squared plus 4x plus 4 plus 4. Okay, so we're basically taking what was in our parentheses before and we're just adding 4 to it. Okay, and so when we add those, we'll combine like terms, we get 8. So notice it went from, this is actually vertex form, which is what we're going to learn today. Now it's in standard form. Okay, now it's in standard form. We learned this. It says find the vertex, and you guys have been practicing this on IXL this past week. I've been working very hard. I've been looking at y'all's IXLs, and but we use this formula. The formula is x is equal to negative b over 2a. Okay, to find our vertex when it's in standard form. So we got to identify what a, b, and c are. Okay, my a value is 1, my b value is 4, and my c value is 8. And I would ask if I was teaching you, do you guys agree with me? And you'd be like, yes, Miss Garner, I agree. Okay, and if not, you'd ask me questions. So now I just have to talk to myself, which is kind of awkward, but it's okay. All right, so I'm just going to plug it in to this formula. I'll do negative b, which is negative 4. Well, x is equal to this. Negative b over 2 times my a value, which is negative 4 over 2, which is just 2 times 1 is 2, and is equal to negative 2. So I found my x value. Now I would ask y'all, how do I find my y value? I'm going to plug it back in. Okay, plug it back into this equation. So when I do that, I'll do y is equal to, sorry, ignore all my scratches, negative 2 squared. I'm just plugging it into this equation. Anywhere I see an x, I'm kicking it out and I'm plugging in a negative 2. And then plus 8, I'm running out of room. All right. Negative 2 squared would be negative 2 times negative 2. I know 2 negatives make a positive, so this is going to be positive 4 plus 4 times negative 2, which is negative 8, plus 8. What happens when I have a negative 8 and a positive 8? They cancel out. Okay, so this is just 4. So my vertex, okay, which I'm out of room, okay, but my final vertex would be, if you can see this, I would write my x value, which was negative 2, and I write 4. So this last question, I'm going to go ahead and write my answer down here. This last question is asking me, okay, do you notice anything about this? Notice any similarities between your vertex, which is this, what we just found, and the original problem? Look at this vertex and look at its original problem. Okay, do you notice that the 2 and the 4 are both there? So yes, this is how vertex form works. You take the opposite of what's inside my parentheses. So if it's positive 2, it's going to be negative 2 for my x value, and it's with the x, so it's not confusing. And then whatever's on the outside my parentheses, you're going to write that as your y. So you can literally, I didn't have to do all this messy work, right? I could have gone straight from here to here to find my vertex. And that's what's cool about vertex form. So I'm going to go ahead and move on down. And so let me zoom out a little bit. you can see this. Oh, my stand's getting in the way. Okay. Sorry, I'm still getting used to my camera. Okay. So the vertex of a quadratic formula, this is the vertex form where h and k. So h and k, we're using different variables because we're talking about a different form of a quadratic formula. So this is the formula, basically y equals, and plus or minus, we can have a plus or minus sign out here, a, which is similar to my a value I had before in my standard form, x minus h. So basically this minus is telling me I'm going to take the opposite of what's inside my parentheses to find this value. Okay, that's what the negative sign is there for. H squared plus k, and k is my y value of my vertex. So looking at this example, I can know what my vertex is. Looking inside my parentheses, I have a negative 2, so the negative of a negative is positive 2, and my y value out here is 6. So my vertex is 2, 6. Write it a little darker so you can see. Okay. So, just as in standard form, the sign in front of the a tells us if the parabola opens up or down. So, if there's a positive sign, so for example, in this first one, right, if I have a positive sign out here, so no negative, right, then I'm going to be opening up. So I'm going to have a minimum value. Min. Okay. Think open up. You want to think open up means min. Okay. Up, min, up, min, up, min, up, min. Okay. And then over here for this problem, notice how we have a negative sign in front of my a value. If it's negative, it's going to be pointed down. So opens down. Opens down. We're going to have a max. So I'm going to do the same silly thing again. Max down, max down, max down, max down. Okay, so you can come up with whatever way you can. So remember, if it opens down, we have a max. If it opens up, we have a min. Okay? And we know that by the sign that is in front of my a value. Negative is down, positive it's up. Okay, so let's look at some more problems. Okay, so hopefully y'all can see this. All right, okay. So again, here's another cool thing. So about the a value, if my a value is less than 0, meaning it's a fraction like 0.5 or 0.5, 0.25, something like that, okay, then we're going to have a vertical shrink. Okay? If my a value is greater than 0, meaning it's like 2, and we're not including the sign in front, we're just talking about this number, okay, the a value. All right, then it's a vertical stretch. So if this number is any number that is greater than 1, camera got a little crooked, number greater than 1, then it is a vertical stretch, okay? And notice the look, it kind of looks like shrink. I would think about like pushing the parabola down versus this is kind of like stretching it out, okay? So things stretching out, it's actually going to look narrower with a stretch and look wider with a shrink, but just think about you're pushing the arms down or like stretching up like you're stretching in the morning, right? Your arms get closer and closer together. Okay, so these are kind of examples that you're going to get on your test and on your homework. Yeah, we have homework. So first of all, find the vertex. All right, that's easy. Remember, we just take the opposite, which would be negative 2, and we keep the sign the same on what's on the outside. So this is a negative 4, so it's going to stay negative 4. So the only thing that changes with these is what's inside my parentheses. You don't change anything on the outside. So negative 2, negative 4 is my vertex, okay? Axis of symmetry, okay? It's the same thing as when we were finding the axis of symmetry for my standard form. We just take whatever the x value of my vertex is, which is negative 2, we write in an equation as x is equal to negative 2. So you can zoom in a little bit, okay? Now, to find whether it opens up or down, we're going to look at the sign in front of my a value. If it's negative, hopefully y'all remember this, negative, we're going to open down, okay? Now remember, down has to do with the max. Remember I said down, max, okay? So you're maybe talking to your dog, down, max, down. Sitting down, maybe, I don't know, find a way to remember it. Okay, but max is going to be this one. So we have a vertical stretch or shrink. So let's look at the number, not the sign in front, but the actual number here. My a value is 3. Now, is 3 greater than 1 or less than 1? Hopefully you would say greater than 1. So this would be a stretch. Okay? And then my domain, y'all, is all real numbers, negative infinity to positive infinity. Another way to write this would be all real numbers. This stays the same regardless. And then my range is going to be my lowest y value, or my lowest y value. So let's go ahead and sketch this. Go to -2, -4, and we talked about it opening down. So we know it's going to just kind of look something like this, okay? And again, this is just sketching. It's not something that has to be super accurate. But now we know what our lowest y value is. What's my lowest? It's negative infinity. And my highest will be my max. My highest y value is -4. And remember, always use a bracket for that. Okay, so I'm probably going to have to stop because I'm out of time probably. So I want you guys to try the you-try problems. There are 3 you-try problems. Try them, and I'm going to make a second video of me working through those, okay? See you guys soon. Bye.